Students, let us continue with the MCQs part 3 for polynomials. Here is the first question. They have given that the sum of zeros of the cubic polynomial p of x 2x cubed minus 3x squared plus 4x minus 5 is 6. This means what? 6 is the sum of zeros. So what you have to find here? We have to find the value of k. So let us recall what is sum of zeros for cubic polynomial. So for cubic polynomial, sum of zeros is given by minus b by a. So for this particular problem, let us list out what are the values of a, b, c and d. A is equal to 2, which is the coefficient of x cube. Then b is equal to minus 3k, which is the coefficient of x square. C is equal to plus 4, that's the coefficient of x, as well as d is equal to minus 5, which is the constant term over here. Now let us apply the formula to get the answer. So we have sum of zeros, that is equal to minus b by a. Therefore, they have given the sum of zeros as 6. Therefore, minus b by a, we can equate it to 6. Now, let us substitute the values of minus b and a. So, minus b is equal to, we have b as minus 3k here. Therefore, it becomes minus of minus 3k divided by a is equal to 2. That is equal to 6. When we simplify this one, we have to take 2 from the LHS denominator to the RHS. So this becomes minus into minus, that is plus. So it is plus 3k, that is equal to 6 into 2. So k is equal to 6 2s are 12 divided by this 3. This implies that k, that is equal to 4. Therefore, the answer is answer B, 4. We'll move on to the next question. Here is the question. We have given with sum and product of the zeros, and we have to write the quadratic polynomial. So what's the question? A quadratic polynomial whose sum and product of zeros are given by minus 3 and 4. So we have sum as minus 3 and product as 4. How to write a quadratic polynomial using sum and product? So we have seen it in many of the problems. The theory here is when we have zeros of the polynomial, or when we have given with the sum and product of the zeros, we can write the quadratic polynomial using this expression. What's that? It is x square minus alpha plus beta, which is sum of the zeros, into x plus alpha beta, that is nothing but the product of zeros, right? So let us just write the polynomial using this expression. So we have x square minus into alpha plus beta, that is sum of zeros, which is minus 3 here, minus 3 into x plus alpha beta, that is nothing but the product of zeros, which is equal to 4. So when we simplify this one, I will get x square minus into minus is plus 3x plus 4. Therefore, the answer is x square plus 3x plus 4. So, if you observe the options, we don't have this answer. Therefore, you can choose the option D, which is none of this. We'll move on to the next question. The question here is the product of zeros of minus 2x square plus kx plus 6. We have asked to find the product of zeros of this polynomial. So here Guys, don't get confused just because of k is present in the polynomial. Okay, just see that what they have asked. They have asked us to write the product of zeros. So what is product of zeros? We have already used it. We have already learnt it. What is product of zeros? Product of zeros is alpha into beta, that is equal to c by a. So if we have the values of the constant and the coefficient of x square, we can write the product of zeros. So how you can write it? You can write product of zeros, that is equal to product of zeros, that is equal to c by a, where c value, that is equal to 6 here, and a is equal to minus 2. So when we substitute c and a, we'll get c is equal to 6 divided by a is minus 2. So this gives us 2 ones are 2 threes are, and we'll take this minus to the numerator. So it becomes minus 3. Therefore, product of zeros, that is equal to minus 3. The correct option is option B here. We'll move on to the next question. Here is the question. Which are the zeros of p of x, x square plus 3x minus 10? So here we have asked to find the zeros of the polynomial. Here guys, we can use two methods. Which are those two methods? One, we can just split this middle term to find the answer, that is to find the zeros of the polynomial. Or what you can do is you can just substitute the values from the options and check whether you are getting the polynomial that is equal to 0. You can go with any way. So let us go with one by one method. If we go with the splitting middle term method, what is the sum here? Sum is equal to plus 3x and product is equal to minus 10x square. So here let us first see the sign set. We have sum as positive. Sum as positive in the sense we should have either both the numbers positive, or we should have one positive, one negative along with a positive number greater. Okay. So here we have product as negative. So what are the conditions for product to be negative? We should have either plus or minus and plus. Anything would be fine for us. So if you observe, the condition which matches for sum and product is positive and negative. Therefore, the sign of factors here is positive and negative. Now, let us see how we can get plus 3 here. As we know, to get the sum as positive, we should have the greater number as positive. Now, what are the factors of 10? We have 5 into 2, we have 10 into 1. So, if we use 10 into 1, we will not get the sum as 3. So, we can eliminate this option. If we use 5 into 2, what we will get? 5 2s are 10. If I use 5x and minus 2x, what I'll get? Plus 5x into minus 2x gives me minus 10x squared, as well as plus 5x plus minus 2x gives me plus 3x. Therefore, the factors are plus 5x minus 2x. Now, let us just apply this to the given polynomial. So, what we have? We have x square plus 3x minus 10. When we write this one, x square plus 5x minus 2x minus 10. So let us do the grouping here. First two terms and the next two terms. After this, we have to take the common out. In the first group, we have x common. So when I take x out, remaining here is x plus 5. In the next group, I have 2 common. I can take minus 2 outside into x plus 5. Therefore, I can write this as x plus 5 into x minus 2. And since they have asked to find the zeros of the polynomial, I can equate this factors to 0. Therefore, the answer is x plus 5, that is equal to 0, and x minus 2, which is equal to 0. This implies I will get the answers as x is equal to minus 5 and x is equal to 2. Therefore, what are the zeros of the polynomial? Zeros of the polynomial are minus 5 and 2. Which is the option correct here? Minus 5 and 2. That is option B here. Correct? So, another method, as I said, you can just apply or you can just substitute minus 5 in the polynomial. Check whether you are getting the polynomial that is equal to, or value of the polynomial is equal to 0. So, let us just check it. Okay. So, observe here, just to cross verify, I'll use the same option and I'll check whether I'll get LHS is equal to RHS. I have x square plus 3x minus 10. So let me check what is the value of the polynomial at minus 5. So minus 5 whole square plus 3 into minus 5 minus 10. That is equal to 5 minus 5 whole square is 25. Then 3 into 5 is 15, and here plus into minus becomes minus 15 minus 10. So when we simplify this one, 25 minus 15 is 10, 10 minus 10 is 0. So this implies that minus 5 is the 0 of the given polynomial. Now let us see the next value, that is 2. We'll find what is P of 2, that is equal to, here 2 whole square plus 3 into 2 minus 10. This is equal to 2 square, that is equal to 4, plus 3 into 2 is 6 minus 10. So 4 plus 6 gives us 10 minus 10, that is equal to 0. Therefore, even 2 is the 0 of the polynomial. Therefore, whatever option we have selected here, that is the correct answer. Let us move on to the next question. Here is the question. The graph of x is equal to p of y is given for some polynomial p of y, then the number of zeros of p of y is. So previously we had seen the graph for y is equal to p of x, and we have written the zeros based on where the graph intersects the x-axis. So here we have given with x is equal to p of y. So how we can find the answer for this one? See here, when a graph of x is equal to p of y is given, then the number of zeros of p of y is equal to the number of times the curve intersects the y-axis. So let us see where the curve intersects y-axis and how many times it is intersecting, and based on that we can choose the answer here. So observe here, we have one point here, another intersecting point here, another here, again one more here. So how many we have? We have 1, 2, 3 and 4. So therefore, what is the number of zeros for the given polynomial? It is answer A, 4. So for today, we are going to end the class. Keep watching, continue learning. Let us meet in the next class. Thank you.